much energy is needed to change 3 kilograms of ice, originally at negative 10 degrees Celsius, to water vapor at 100 degrees Celsius? So I guess we could just say how much energy is required to completely vaporize 3 kilograms of ice, originally at negative 10 degrees Celsius. Number one, we need to figure out how much energy will be needed to bring the ice to its melting point. Negative 10 degrees Celsius, ice will not melt. We're going to assume 1 atm, so we're going to use 0 as melting point and 100 as boiling point. So we'll need to find out how much energy is necessary to just bring the ice to its melting point. It's going to take energy to do that. We'll need to figure out how much energy is necessary to melt it, to make it liquid water, but it will still be at 0 degrees Celsius. It'll just be liquid. Then we need to find out how much energy is necessary to bring this now liquid water from 0 degrees Celsius to 100 degrees Celsius. Then we need to find out how much energy is necessary to completely vaporize it. Okay? That's what we're looking for. So to bring ice to its melting point, we need the mass of the ice, the specific heat of the ice, and the change in temperature of the ice. To melt it, to change phase, we'll need the mass of the ice times the latent heat. Which latent heat do we want? We're going from solid to liquid. Fusion. Now, is this going to be plus or minus? Do we have to put energy in or take it out if we're going to melt it?
Put into it.
So we're going to plus. To bring it from 0 to 100. Now, do you agree that if I had 3 kilograms of ice, I still have 3 kilograms of liquid water? The mass doesn't change.
Yes.
Okay. So I'm going to still call it mass of ice. But now we'll have to, it's liquid water now, so we'll need to use the C for water, liquid water, and then the change in temperature. And then the mass times the latent heat of vaporization. So the mass of ice is 3 kilograms. We can factor that out since it's in every term. C of ice is 2090 joules per kilogram Kelvin. The change in temperature. The final temperature will be 0 degrees minus the original temperature was negative 10 degrees. 0 minus a negative 10 is positive 10. A change of 10 degrees Celsius is the same as the change of 10 Kelvin. Latent heat of fusion was the 3.33 times 10 to the 5th joules per Kelvin, kilogram. C of water is the 4190 joules per kilogram Kelvin. Change in temperature. For this step, the final temperature is 100. The initial temperature is 0. So a change of 100 Kelvin. Can someone look up the latent heat of vaporization, please, for water? Thank you. Look at that. It requires even more energy, a ton more energy, to vaporize water than to melt it in the first place.